All right, so in our class on Monday, we looked at the mean, we looked at the median, and we looked at the mode for ungrouped data. In today's class, we are going one step further. We are going to find the mean, mode, median, as well as the quartiles for group data. Now, when we analyze data, averages are still an important measure. What do I mean by averages? I'm talking about the three statistical averages, the mean, mode, and median. However, the averages do not give us a total picture. Just as there are different ways to describe the central tendency of a set of data, there are different ways to measure the spread or dispersion of data from its central values. Now, what we are interested in and what CSEC is interested in is the quartiles. So where the median divides a set of ordered measures into equal parts, we have a lower quartile and an upper quartile. So I know that you all would have met the quartiles some time ago, but let us recap what are the quartiles. So the median is the middle, we know that. The middle of what? The middle of the set of data. So N is the frequency. So they may say of 100 students, of 60 students. So the median is a half of N, but the median isn't really the 30th or the 50th value. You have to go on the chart and see where does that lie, and that will give you the value of the median. Now, the lower quartile is a quarter of N because the quartiles divide the data into 4 parts. So we have upper, lower, median, and the upper quartile is 3/4 N. So let us write everything that I'm underlining. You are to write it, the quartiles, and you are writing these 3 for me. Also, the range, you're writing the range is the highest value minus the lowest value. All right, then we have what we call the interquartile range, or the IQR, which is the upper quartile minus the lower quartile. So go ahead, whatever I have underlined on my screen, you want to take it down, please. All right, are we finished writing?
Yes, Miss.
All right. So we have a couple of new terms: quartiles, lower quartile, median, upper quartile, range, interquartile range. So especially in the statistics question, which is question 5 of the paper 2, we are required to know about these terms, right? Also, we are sometimes asked to find the semi-interquartile, and the semi-interquartile range is a half of the interquartile, which is Q3 minus Q1. So write down this word and take down this formula for me. And we're going to do an example.
Finish, Miss.
All right. So we are going to do this table. Now, I want you to draw as quickly as you can the table. So there are 4 columns and all the rows. So go ahead. And let me hide these values because we're not ready for them as yet. So go ahead. Draw the table in your book. Please let me know when you all are finished drawing the table.
Finish, Miss.
All right. So the first thing we are going to complete is the upper class boundary. Now, I remember some time ago asking you to find the upper class boundary and the lower class boundary. So let us examine these two numbers. We can do it for any two numbers. So what we are looking at is the upper class limit of one interval of the first interval. Now, the word upper should indicate that is the highest of the two values. So the upper class limit of this interval is 10. And the lower class limit of the second interval is 11. So for us to find the upper class boundary, we take the higher value and we subtract the lower value and we divide by 2. So here we will get a half, which is 0.5. So now the upper class boundary is the upper class limit plus 0.5, and the lower class boundary is the lower class limit minus 0.5. But what exactly does this mean? So if we have to cut ribbon in centimeters, and say for instance, there's an error of measurement, you cut a length of ribbon that's 10.1 centimeter. You cannot discard that piece of ribbon. It must go together with the other sets of ribbon. So the limits and the boundaries are what we call the ends of the distribution. So it means that for a particular value of length of ribbon, there must be a start and end, so we can include values that are not listed here. So if I have 5.5, a length of ribbon, that's 5.5. There's no number here as 5.5, but we need to include that in our frequency data. So it means that the highest value that the length of ribbon could be to fall in that interval is 10.5. And the lowest value will be 5.5. So any length of ribbon within that range of numbers, 5.5, 5.6, 5.7, 5.8, 5.9, any length of ribbon from 5.5 to 10.5 will fall in interval 1. The second one, the lower limit is 11. If we subtract 0.5 from 11, we'll get 10.5. And if we add 0.5 to 15, we get 15.5. So any length of ribbon, 10.5, 10.6, 10.7, 10.8, will fall in that second category or in that second interval. So what we need to plot is the cumulative frequency curve. So we are taking these values, which is the upper class limit, and we are simply going to add 0.5. But we are unfinished as yet. You will complete this table for me. The cumulative frequency is what we call the totals coming down. So the first value is 0. The second value, 0 plus 2, which is 2. The third value, 2 plus 4, which is 6. Then we have 6 plus 8, which is 14. So I want you to complete this column and this column here for me.
Good afternoon, Miss.
Good afternoon, Sinisha.
Miss, you receiving notebook to write
Yeah.
down?
Yes. All right, let me know when you all are finished. We finished?
I'm still writing.
All right, let's see. These are the values you are supposed to get. Did you all get that?
Yeah, miss.
This one, something wrong here. This is supposed to be how I get these numbers here just now. All right, let me do it here. All right, let's go. So we have 10.5, 15.5, 20.5, 25.5, 30.5, 35.5, 40.5, and 45.5. Did you all get that?
Yes, miss.
2 plus 4 plus 8, right? 14 plus 14, which is 28. 28 plus 6, 34. 34 plus 4, 38. And 38 plus 2 is 40. Did you all get those values for the cumulative frequency?
Yes, miss.
All right. So this was just a basic introduction into statistics. So we're going to apply the knowledge that we have now into the questions. So you all open your paper 2 booklet and please turn to page 179. Is anyone still writing? Is anyone still writing?
No, miss.
All right, so let us go to January 2022. And we are looking at question 5. It's on page 179. All right, did you all find it?
Yes, miss.
All right, so let's do this question together. For those of you who don't have the question, you could follow along on my screen. The cumulative frequency diagram below shows information about the distance that each of 120 students. So underline 120. 120 is what we call the cumulative frequency. So you could write that. So N is 120. 120 students walk to school on a particular date. So let me know when you are finished writing it.
Finish, Miss.
Now I need to blow up this so you can see it. We need to figure out the scale on the y-axis. So 0 to 20, here is 10. So this means that every 2 centimeters is represented by the small block. So we are really counting in twos. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. Do you all see that in your graph?
Yes, Miss.
Yes, Miss.
Now, I'm going to give you a minute. How many students walked at most 1 kilometer on that day? So 1 kilometer, we're going straight across on your graph and you're going to meet the y-axis and read off that value for me and write it in your book. We will do it in a minute. So we want to know how many students walked at most 1 kilometer. So we find 1 kilometer on this graph and we read off the corresponding cumulative frequency value. Remember that every tiny block represents 2 persons. So if I blow up my screen here, this is 30, this is 32, this is 34, and the value of the arrow is 36. Did you all get it?
Yes, Miss.
So 36 students. So here you would have scored 1 mark, and that wasn't hard. All you needed to do in this question was to read off the value from the graph. All right, so let us continue. 36 students walked at most 1 kilometer. Now, using the cumulative frequency diagram, determine the estimate of the median. Remember, the median is the middle, but the middle of what? The middle of the cumulative frequency. That is why I ask you to write this at the start of the question. So the median is a half of 120. The median is the 60th value. The median is not 60. Notice this is 1 mark. If you put that the median is 60, you would get it wrong. So the median is the 60th value, right? Now, the lower quartile, remember, that is 3/4 of n. And the interquartile range is the lower quartile, upper quartile minus the lower quartile. So the lower quartile is 1/4 of n, which is 1/4 of 120, which is the 30th value. So take down this, go to your graph, and see if you can read off those values correctly. I'll be back in 1 minute. And let us read the 60th value. So the median is the middle of the cumulative frequency data. The cumulative frequency is 120 students. Half of 120 is 60. So we go into our graph and we are reading off the 60th value. So we're going straight across and we are coming downward. Now, so we have 10 intervals between 0 and 0.5. So let's see. This is 0.1, 0.2, 0.3, 0.4. So 2 small blocks represent 0.1. So this will be 1.1, 1.2. This value here is 1.3. So we need to know how to read the scales. If this here is 0.5 and we have 10 small divisions in between, it means that 2 small blocks represent 0.1. And it is a level of accuracy they are looking for. So the median is 1.3. Did you all get that?
Yes, Miss.
All right, so let's write that down. 1.3 kilometers. And here we would score 1 mark. So we go into the lower quartile, which is the 30th value. So the 30th value, we know 30 lies here. We're going straight to touch the curve and we coming straight down. You see how the values lie exactly on the line? So we counting. This is 0.6. This is 0.7. This is 0.8. So this value here is 0.9. Did you all get that?
Yes, Miss.
All right, so let's do that. Here is 0.9 kilometers. From the notes that we wrote down on statistics, we have to find what we call the IQR, which is the upper quartile minus the lower quartile. We have the upper quartile, we have the lower quartile, so we need to find the upper quartile. So the upper quartile is 3/4 of n. So it is 3/4 of 120. So 3/4 of 120 is the 90th value. So go to your curve and read off the 90th value. You're going straight across and then you're coming downward. So go ahead. This is Q3. This is Q2. This is Q1. So let's read off this number. So here would be 1.6, but this isn't 1.6. It is midway between 1.5 and 1.6. So take the calculator, 1.5 plus 1.6 divided by 2, I have 1.55. So this is midway between 1.5 and 1.6. So this value is indeed 1.55. So let's go. So Q3 is 1.55 kilometers. Q1 is 0.9 kilometers. Work out for me the interquartile range, which is Q3 minus Q1. All right, what is the answer?
0.65.
0.65 kilometers. Very good. A student is chosen at random. Now, CXC likes to associate probability with statistics. They go hand in hand, right? So the question asks, what is the probability that a student walked for more than 1.5 kilometers on that day? So we are going to the curve. We're finding 1.5. And we're going to see how many students walked for 1.5. So we're going 1.5 straight up, and this is the value here. Read off that value for me. So let's look at it. It is the next block after 80. So this is 82. So it means that this number of students here walked for more than 1.5. This is the curve. So the number of students is the difference between 120 and 82. Work out that for me. 120 minus 82.
38.
38. So remember, the cumulative frequency is the total coming down. So if we have to find the number of students who walk more than 1.5, it is really this portion of the curve. So we're not concentrating on this because here this is 82. So if this part represents 82, this part will represent 38. So probability is the number, the probability, the number of students who walked more than 1.5 over the total number of students. So we have 38 over 120. Simplify that to the lowest terms for me. So 2 could go into 38 19 times, and 2 could go into 120 60 times. Did you all get that answer? Did you all get 19 over 60? Did anybody get this answer? All right, is anybody still writing?
No, miss.
All right. So look at the table and see how best you can fill the missing values. Go ahead. All right, let's see. How are we going to get the value for the midpoint? How are we going to get the value of the midpoint?
Miss, I add 0.50.
If you add 0.50, that is the boundaries. The midpoint is the lower class limit plus the upper class limit divided by 2. So work it out for me. All right, who has an answer? Who has an answer?
1.75, Miss.
1.75. Now, even if you didn't know what to do, some of the values are given. So the statistics question is a question where we can score some marks, because think about it. Midpoint is in the middle of the two values. So if we get 0.25, we add 0 and 0.5 and divide it by 2. If we get 0.75, we add 0.5 and 1 and divide it by 2, and so on. Another way of working it out, this difference here is 0.5. So if we add 0.5 to 0.25, we'll get 0.75. If we add 0.5 to 0.75, we'll get 1.25. If we add 0.5 to 1.25, we'll get 1.75. So here we would have scored 1 mark. Whenever CSEC brings cumulative frequency, they always insist that you work backward to find the frequency. So the cumulative frequency is found by the running down total or the total coming down. Now they give you the CF and you have to work backwards to find the cumulative frequency. There's no need to find the boundaries, because if you notice, the values here are the same. So let's see how they get 12, 24, 46. So we're looking at 0.5 on the graph. We're looking at 1.0. We're looking at 1.5 kilometers. So let's go. So let me just clear some space here. So we're looking at 0.5. We want to know how they got that value. So at 0.5, we're going straight up to 0.5 and we come in across. So remember, just now I told you each small block represents 2. So this is 12. So that is the first thing they have, 0.5 and 12. The second one, so we have that 0.5 and 12. The next one is 1.0 and 24. So let's see how they get that. 1.0 goes straight up and we are going across. So this value here is 30, 32, 34, 36. But the value that they got is 24. Could somebody tell me how they got 24 from that, from those two values? How did they get 24 from 36 and 12?
Just to take it away by 12.
So you take away 12 from 36. Is that what you're saying, Amrita?
Yeah, Miss.
Right. So let me draw a little table here. We start off with 0.5. The frequency here was 12. Then we go to 1.0. The frequency is not 36, but the cumulative frequency here was 12. This is 36. So this value here is 24. Because 24 plus 12 is 36. Do you all understand so far?
Yes, Miss.
So we're going to 1.5 now. So we're going straight across here to 1.5. Right, so 1.5 has a value of, this one, 1.5 has a value of 82. So here is 82. So what value am I going to put here now? What is the difference here? 82 minus 36. How much is that?
46, Miss.
46. Let us check with the answers that we have. So we have 1.546. So we are on the right path. We have to do it for 2. So let's go. Find 2, go straight up and read off the value for me on your graph. Go ahead. Read off the value on your graph. And this would be for 2.0. All right, what value did you all get here? This is 110. 2 more than 1 is how much?
112.
112. So the difference here, 112 minus 82. How much is that?
30, Miss.
30. Right. We're going to the graph now. Here is 30. Now, how many students did we start off with? We started off with 120. So we know the frequency is 120. So add all of these numbers and take it away from 120 and put the answer here. What is the missing value?
Miss, I got 6.
6. Did anybody else get 6?
Yes, Miss.
Right. Fill this 2 rows. This is f by x. This is the f values and this is the x values. So fill these 2 rows. All right, who has an answer for this row and this one? 30 by 1.75.
52.5.
52.5 and 6 by 2.25.
18.5.
Very good. Now you're probably asking yourself, why, if we're not drawing a graph, did they ask us to find midpoint? Is this the end of the question here?
Yeah, miss.
So we're not supposed to find the mean. Oh yes, look. Calculate an estimate of the mean. You see why we have to read the question and underline what they ask us? So filling the table is one part of it, but the next part is to find the mean. So in order to find the mean, because the data is grouped, we had to find the midpoint. Remember, this is group data. I do not have a single value to multiply the frequency. So to find a common value is where we find the midpoint. So the formula for mean is the sum of f of x divided by the sum of f. We know the total frequency is 120. Find for me this total. All right, what's the total? What is the total? F multiplied by X. What is the total of this column?
150.
150.
150. So 150 divided by 120 is?
$1.25.
1.25. 1.25 kilometers. So that wasn't too bad. So once we are all finished, we are turning to page 151 in the booklet. Is anyone still writing? Is anybody still writing?
No, miss.
No, miss.
So we are going to page 151. So this is July 2021, page 151. 100 students, underline that, were surveyed on the amount of money spent on data for their cell phones during a week. The table below shows the results as well as the midpoint. Well, you know, if they ask for a midpoint, they may very well ask to find the mean. So determine the modal class. So they ask, these are classes. which of those classes have the highest number of students? So, which class has the highest number of students? Who could tell me? Which class has the highest number of students? Is it this class, this one, this, or this one? Which one?
Let's say 70 to 80.
70 to 80. So you are writing it exactly how they gave it to you. 70 less than x less than or equal to 80. And for doing just that, nothing else, you will get 1 mark. So if you don't have it, take it out. We want to find the mean. So just now we found the mean. So we need to extend our column and find f of x. So go ahead, extend your table in your book and you're multiplying f by x. So you're multiplying 7 by 55, etc. And I want the total of this column and I want the total of this column. Go ahead. All right, are you all finished with the values? Are you all finished with the values?
Yes, Miss.
So you have 385, 11 by 65, 7, 15, 31 by 75, 2,325, 29 by 85, 2465, and 2295, 2090. Well, we know it's 100 students, so this is supposed to give us a tally of 100, right? Let's add up those values. I got 7,980. Did anybody get that?
Yes,
Yes,
Miss.
Yes, Miss.
So remember the formula for mean. The sum of f of x divided by the sum of f. Work it out. All right, 79.8. Did you all get that?
Yes,
Yes,
Miss.
Miss.
Yes, Miss.
Damien reports the median amount spent is $84. Briefly explain why Damien's report could be correct. And this is 1 mark. So the median is a half of n, but we know there are 100 students in the survey. So 100, half of 100, the median is the 50th value. So the 50th value will lie. So write down that. Let's go and investigate and see where this 50th value is going to lie. So take down that what I have there. All right, are we finished writing?
Yes, Miss.
Now let's see where this 50th value is going to lie. Now, 7 students spent between $50 and $60. So we didn't reach student number 50 as yet. So here we have the CF. 11 spent between 60 and 70.
So if we add 7 and 11, we will get 80. We did not reach number 50 as yet. 31 students spent between 70 and 80. So 18 plus 31 is 49. So we are getting closer, but we didn't reach student number 50. So if we add 49 and 29, we will get 78. So which means the 50th student would lie in this interval. And the mere fact that Damien chose a value that is between 80 and 90 means that his estimate of the median is correct. Do you all understand that? Would you all like me to go it over?
Yes, Miss.
All right. So if we have all the students lined up from number 1 to 100. So we have 1, 2, 3, 4, 5, 6, 7. So this first 7 students, they spent between $50 and $60. Then comes the students who who used more money than that. So we have persons 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So these are the second group of students. They scored between 60 and 70. They used that amount. So this is the first 7 and this is the next 11. So we're going down in a line and we didn't reach number 50 as yet. So we're going down. From 90 now, we're going all the way up to person number 49. And they are going to utilize $70 to $80. But we didn't reach, so we're going down the line. It's like the line extending down the corridor. So the next group of students is up to 78, and they scored between 80 and 90. They used between 80 and 90. So that is the fourth step. So this is the first group. We didn't reach 50. The second group, we didn't reach 50. The third group, we didn't reach 50. But in the fourth group, person number 50 would lie in this fourth group. So that is why Damien could be correct. Do you all understand now?
Yes, Miss.
All right, so take down whatever you need there on the screen. And it is like we are counting downwards. So whichever explanation you prefer, you are to take it down. This is the 50th, and this is the median between this interval here. All right, is anybody still writing?
No, Miss.
All right, so let's write something here. Would lie between 80 and $90. So Damien's report is correct. All right. Take a few minutes. I am sure that you all could fill the table in. So take a few minutes and fill the table. We're almost there. We'll finish a little bit after 6 o'clock. As soon as we are finished with this part of the question, we will end the class because I realized I didn't give you all a break. So complete the table. Let's see how quickly we can wrap up this question and we will bring the class to an end.
Finish, miss.
All right, let's see. So if you notice, the total here is 48. So it means that 15 and 14 and some number here under the column cycle supposed to give us a total of 48. So here will be 48 minus 15 minus 14. Here is 19. Did you all get it?
Yes, miss.
Right? Now, if you notice, the total here is 100. So 100 minus 48 is 52. So this missing value is 52 minus 18 minus 26. Here, this is 8. And, well, this value here, 100 minus 23 minus 40, this is 37. So we would have scored 2 marks, right? A student is selected at random. We want the probability that he or she was being driven to school on that day. So they did not tell us if it was a boy or a girl. They said he or she. So the probability that he or she was being driven is the number of students being driven over the total number of students. So work that out for me. How many students are being driven and what is the total? The total is 100. So we could underline that. How many students are being driven?
40.
Right? Simplify that answer to the lowest terms. I have 2/5. All right. One of the girls is selected at random. What is the probability that she did not cycle. So if she did not cycle, how did she reach the school? If she didn't cycle, what mode of transport did she use? The girl didn't cycle. What other modes of transport are there?
Walking, children.
Walking or driving. So the probability did not cycle is, we are looking at the girls. The number of girls who walked and drove over the total number of girls. So work it out and write down the answer to the simplest form. So you're adding this figure and you're adding this figure. We're dividing it by total number of girls. What is the value? Or what is the fraction, I should say? So let's add 8 plus 26, that is 34 over 52. This is 17 over 26. Did anybody get that?